morning, Geometry. It has been a wonderful weekend. I hope you had a great night. I hope you're ready for Monday morning geometry class. I know you're depressed. I'm still not here. But guess what? Only 3 more classes and I'll be back. Today, Wednesday, Thursday. I'll be back on Friday. Can't wait to see you. I'm sure you can't wait to see me. Well, here's what we have going on. We've been covering some really important stuff with transversals and parallel lines. I hope you learned that. We will be covering some of that. I will be doing a review with you when I get back on Friday. We'll just kind of review all the lessons we talked about. We'll go through some different homework assignments, and I'm looking forward to helping you. I'm sure some of you are a little perturbed by now because I keep calling on you, and I don't know if you always have the answers right. And how am I getting a participation grade? I know. But just do your best to bear with me as we go into this geometry section. This is my favorite section because this is actually geometry. Something you will be doing, and we have learned this, and we'll talk through this as we go. One of the things we do, and let's go over here real quick. All the way over here to the side. Can you see me over here? You know what? How about we do this? We'll just move the whole thing over. Now you've done it. Now you're all down on the floor. I hope you didn't get sick on that ride. All right, so here you go. We're going to go over here for a second so I can draw something on the board. I miss drawing on the board. PowerPoints are great, but sometimes it's just nice to just see it drawn. Now, we are going to be talking about something that's so important. And I can't tell, can you see me? There I am, okay. I'm right back in after with you. All right, so here we go. So what we're going to be talking about, I think, we flipped it. Oh boy, now we're in trouble. All right, so here we go. So what we learned in the first chapter, I taught you about a Cartesian plane. What is a Cartesian plane? Cartesian plane is where we can graph points. It is an XY axis. So it's X. Now this is Y and this is X. Now remember, I also told you to label the quadrants. This is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. So we have 1, 2, 3, and 4, and that's awesome. What is this point called where the 2 intersects, where the Y and the X intersect? That is called the origin. And we know that that is going to be always 0, 0. Now, does that look familiar to something you haven't seen? Something like that, right? Everybody's on the same page with me, right? So what we're going to be doing today is we're going to be talking about slope. We're going to be talking about slope. We're going to talk about distance. We're going to talk about midpoint. All of those are going to be using this Cartesian plane. So it's kind of a little different lesson. We're going to stray from our proofs and things like that to do what this Cartesian plane is. So as we flip back over to our new other side, back to our PowerPoint where we'll be teaching from today, it is going to be an interesting class, I have a feeling. Some of you are on point and some of you are fast asleep. All right, but Monday, and it's great, we're learning something new. Here we go, distance, midpoints, slopes. Distance, midpoints, and slopes. Now remember, we have our Cartesian plane, and now when we go to look at this, we have a Cartesian plane. This one's a little smaller, quadrant 1, quadrant 2, 3, and 4. We have our origin. Now, point P. So everybody see point P there? I know it's small. How do we find out what the coordinate is for point P? Well, what do we know? The Y value is the height, how high it goes. What is the value? 1 and 2. So it's up 2, and it's over negative, remember negative, 1, 2, 3. So it's negative. So how would you find it? The X is always written first because in alphabet, X comes before Y. So therefore, it's an XY coordinate. So these are some important things you'll need to know. An ordered pair, like for P, is going to be what? -3, 2. The x-axis, the x is where it crosses the x, and the y is where it would cross the y if it was all the way over there. So it's going to be -3 and 2, and that's the point P. Now, that's an ordered pair. Those are your coordinates. Measured, the measure is the reference. That's the point of reference here, the origin, 0, 0. Along the x-axis, here's your x-axis, here's your y-axis. The two are, they're parallel numbers that go all the way up and down, all right? Any questions so far on what we just did here? I know it was brief, but I think everybody's on board with me that way. Now, we are going to try to find the distance formula. Now listen, I know this is different, it's a little fuzzy, and I'm hoping you can see it, all right? And I'll go over it with you. But what we're trying to find is point A here, point B here. So A to B. And what we're trying to find is what that distance is. Now, how do you think we find that distance? So how can we find that distance? Well, what we have to do is we have to take our x's and our y's and our x's and our y's and figure out what that would be. Now if you look at it, it forms a triangle. Does everybody see this? A triangle, A here and then there, okay? So we can see that triangle like this. And so what it is we're going to try to find this distance up that curve, that line. And that's important, and they're going to give you an equation that you're going to use to solve that. And I know you can't read those numbers, and that's okay. We don't need to read those numbers yet. We'll do it on when we do some examples. Here's the distance formula. The distance formula is, now, our A is x1, y1. Our B is x2, y2. So when you have those, then you just plug them into your formula. The formula they're going to give you is this one right here. D, the distance, is equal to the square root of, parentheses, x2 minus x1 squared plus y2 minus y1 squared. So what you're doing is you're squaring that information. That's how you get this here, okay? All right, so it is the absolute value of x2 minus x1 and y2 minus y1. All right, so write this equation down. The distance formula is x2 minus y1 parentheses squared plus y2 minus y1 parentheses squared. And that all is inside of a square root. All right, any questions on that? So far, everybody good? You have that distance. All right, so you have that formula. That's important, you have the formula. Now, here we go. Our next slide is going to give us an example. So we're going to solve for an example of distance, okay? So, can you see the distance formula? The distance formula is -2, 5, and 4, 1. So those are our 2 points. Now remember, what you have to do is you have to make one or the other your x1 and y1 and x2, y2. So let's make this x1, y1, x2, y2. So as we do that, now what happens is we can now decide and decipher that this is, we got to put these into our equation. So now remember, what's our equation? What is our equation? Anybody want to remember what the equation was? So whenever I do something, you always write the equation first. So here's our equation, boom, 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 there it is. See how fast I can write? And I know some of you are trying to keep up with me, so good, get that equation written down. Distance equals the square root symbol, x2 minus x1 powered squared, plus y2 minus y1 powered squared, right? Now, remember, what's our x1? Our x1 is what number? -2. Our x2 is what number? 4. So what number goes here? Somebody tell me what number goes here. Brandon, tell me what number goes in for x squared. The answer is 4. Good job. What number goes in for x1? And that is -2. Now remember, the key component to doing these problems, the most important thing you can remember, is that if this is x1, this has to be y1. You can't flip-flop. You can't take one from here and take one from there. You can't do that. You won't be able to do that. It will not work. So you have to make sure that is the one thing you will have to make sure to do. Now, so watch carefully. So what would the y1 be? 5. And the y2 would be 1. So here we go. Write it in. Square root 4 minus. Now notice they put a -2 in there. His second little parentheses, squared plus 1 minus 5. Because remember, a minus and a minus becomes a minus and a minus becomes a, what, Elisa? Positive. Good. So that becomes positive. So watch. 4 plus 2 is 6. And 1 minus 4 is, or minus 5 is 4. So, look at our next answer. So we got 4 plus 2 is 6. 1 minus 5 is a -4. Now, when you square 6, what answer do you get? Sarah? 6 times 6 is 36. Good. And negative 4 times negative 4, Joel, is a positive 16. 16 plus 36 is 52. And your answer is the square root of 52. Now, can you get a little bit further? You can. You can take, and we will go over this as we get there, 2 to the square root of 13. How do you do that? I will show you very briefly. And that looks like this. 52. 2 goes into 52 how many times? So that is 26. 2 goes into 26 how many times? 13. So 13, you have a pair. What happens is this. I grew up in the jungle of South America, and one of the things they taught me there was this, that when twins were born, you have two things. One thing you know about twins, one thing is this, is that twins there's an evil twin and a good twin. Good and evil. The problem is that in their culture is that the only way they would be combined back together, get the evil part, the good part, is by killing them and burying them in the same grave. That is not something we believe, but that's what they believed. So what they would do is they would take their twins and they would take them outside the house and they would bury them in one grave. So that's why you have the pair of 2s outside the house and the 13 left inside the house. And that is a really crude way to remember it, but it is something you will remember, okay? So 2 times the square root of 13. So it's the twins buried outside the house in one grave. So that's how you would do that kind of a problem. The other answer, if you use a calculator, is 3.61 is your answer, okay? So the distance, and I would like it to look like this when you're done. 2 times the square root of 13. That's the best way to have that. All right? Any questions about doing the distance formula? Okay, so that's one example problem for distance formula, okay? All right? Once again, what's the key? What's the key to doing the distance formula? It's what? Good, Elisa. Making sure that these are both x1, y1, and these are x2, y2. If you mix these up, you're in trouble, all right? All right, next. Midpoint. What is a midpoint? Well, we talked about this before. What is a midpoint? The midpoint is when we have the middle of a line. The middle, they have 2 equal sides and 2 equal halves. So, when we talk about it on a diagram like this, what do we see? We have 2 points, right? We have an A and a B. And we see that A, we can go down this line, we can count all the way down here, and we can see how far it would be for that A to go up, okay? And we have to see how far that is, right? So from your X point and your X point, your Y point, your Y point, how far up it is. So what you're gonna do is you're gonna try to find this location, this center location in the middle. So the equation you will use for midpoint is this one. The equation you'll use is the middle point here is this. x1 plus x2 over 2, parenthesis, comma, y1 minus plus y2 over 2. So what you're doing here is this. You have what is called a midpoint. A midpoint is a point on that ordinate plane, an ordered pair, a x value and a y value that will give you where M is. So once again, what you're going to look to and write down is this midpoint. So what is a midpoint? And your formula. x1 plus x2 over 2. y1 plus y2 over 2. I will be handing out these PowerPoints so you'll have this in front of you when you're doing the homework problems. So don't be alarmed or fearful or worried. You will be able to do this and see this. All right, make sure you take some notes on this, and then that way you don't have to write a bunch of notes and try to keep up with me. I know I'm going fast for some of you. All right, now, so the midpoint is, once again, x1 plus x2 over 2, y1 plus y2 over 2. Now, let's do an example. Once again, what's the key? The key is to make sure that your ordered pairs, x and y, are going to be the x, if these are the 1 values, and then these are the 2 values, keeping them separate. So, once again, let's pick which ones we want. This is going to be x1, and this is y1. This is going to be x2, and this is going to be y2. So, we're going to find the midpoint. So remember, what is our equation for finding the midpoint? The equation is, advanced quickly. I'm not that fast and you're not that fast, but let's just do it slowly. x1 plus x2 over 2, comma, y1 plus y2 over 2. So what do we have? We have our points, remember? So what is the x1 value? Here it is, -2. Our x2 value is over here as 1, so we bring that over. So it's -2 plus 1. And the y1 is 3, and the y2 is 5. So 3 plus 5. So here's what it looks like. -2 plus 1 over 2, 3 plus 5 over 2. So somebody do the math for me very quickly. -2 plus 1, Brandon. -2 plus 1 is -1. Good. So -1 over 2, and 3 plus 5, Grayson, 8. Good. 8 divided by 2 is 4. All right, so our answer is -1/2, comma 4. So that would be the midpoint of that problem. So, are there any questions? Are there any questions about that information? Good. Let's try another one. Find the coordinate, and this is a little different. Find the coordinate of B. So now let's think about this. Find the coordinate of B. So let's say I have a line right here, okay? And I know it's not going to be perfectly straight like that, but that's where it fits in our little drawing, okay? And now watch. We're looking for B if we know that M is going to be 1, -1, 1/2, and A is located -3, 4. Now listen carefully. Yeah, it's definitely wrong. Let's do this. Let's change it. Let's put B over here. Let's put this over here, -3 and 4. Good. Now, what it wants is it's saying that M is the midpoint. So we're looking for the other side. So how would we find that other side? Now think about this for a second. We're going to reverse what we're doing. We're going to reverse what we're doing. Now we've got to remember, what is our equation? So we have one of the points. Let's say this is the x1, y1 point. We're looking for the x2, y2 point. All right? x1, y1, x2, y2. Now, this is our midpoint. So how do we solve for the midpoint? Somebody tell me what the equation is for the midpoint. The equation for the midpoint, Jake, is that. So we have this. We have -3. So remember, it's this. Our equation here is this, which equals our midpoint, which is -1, 1/2. Okay? So when we plug in here at 4 and here at -3, what we're looking for is these two numbers, and that gives us our B coordinate. Okay? That gives us our B coordinate. So how do we solve that? How do we solve that? Now this is really crucial here. What you're going to do to solve this information right here is you're going to take this one and set it equal to this. So, carefully doing this over here, -3 plus a y2 over 2 equals -1. So what are we going to have to do? We're going to have to get rid of something. We're going to move some stuff. So the first thing we're going to move is got to get rid of the 2 in the bottom. That cancels out. And we're left with -3 plus y squared, or y to the 2, equals -2. Now class, how can I get y2 now? Or x2, so x2. Okay, x2. What are we going to get? I have to move the -3 over, so I go +3, +3, x2 equals 1. So we have our x2 value. Okay? We have our x2 value. And I know this is difficult, but it's good practice to work backwards. Because a lot of times what happens when we do these problems, we do this math, we do it one way, and then we don't figure out how to flip it and do it the other way. So how do we find y2? So remember, we use our little equation here, and we set it equal to 1/2. So I'm going to have to erase some stuff so that we can get it. Did everybody get that written down? So everybody find where we got x2 from. Okay, so we took our x2 formula, -3 plus x2 over 2 equaling -1. So now, how would we find the second one? I'm just going to erase like this. Well, isn't that nice, right? See how easy that was? Okay, so it's 4 plus y2, and this all equals, equals 1/2. So remember, what's our first step? We're getting rid of the 2 on this side. So we multiply by 2, that cancels it out. Multiply by 2, which, by the way, cancels out. So we're left with 4 plus y2 equals 1. We subtract 4 from both sides. y2 equals, I hope you can see this, -3. So our ordered pair is going to be 1, -3. All right, anybody have any questions on that? So I'll show you, well, I'll go through it with you one more time with their drawing. But everybody see how we did that? Yep, okay, so we multiply first by 2 and then subtract. All right, so here's what you're going to end up with. All right, so they do it this way. Same thing, just repeating what we did, but I showed the work. So the work was -3 plus x2 over 2 equals -1. And then this one over here, see? 4 plus 1/2 over 2 equals 1/2. So when we do the math, gives us 1. When we do the math, gives us -3. So our ordered pair for B is 1, -3. All right? So that's midpoint. So we've done distance, we've done midpoint. We did the midpoint backwards. You guys are really paying attention really closely. And I like it. I know this is difficult. I know this is hard. But you are listening well. And depending on how far you've gotten on this, we can keep going. And we're almost done here. The last one is slope. Last is slope. Some of you may have learned this last year. You may have learned it. You may haven't. If you didn't learn it, that's fine. If you did learn it, great. I'm going to reteach it a little bit anyway because I think it's important. Okay, but this all is coming together in one section, so it's a lot of information, and honestly, it is really extensive. Okay, but I think you'll do fine. I think you'll do all right. I know it's not easy though, so just keep bearing with me. And here's what we got. So we start with slope. Okay, when we talk about slope, what we have is 2 words that are come in play. The 2 words are rise over run, and so what we'll see is this. What we see is our slope, which, by the way, our slope is always going to be represented by a lowercase m. When you see the lowercase m in a drawing or in an equation, that is representing a lowercase m represents the slope of a line. So we have the slope of a line, we have equals. Now watch, we have rise over run. The rise and over the run of an equation. So when we have a line, and I won't use red because you can't see red. When you have a rise, it goes like this. And you can draw this thing here, and you have the rise. This is the rise, so this is rise. And this is the run. Okay, so let me ask you a question. If this is the rise, what value, what axis are you going to be using to compare that? Okay, it's the rise or the y. And the run is the x value. So you have the run, rise. So if you look here, it says the vertical change, which is the up value, and the horizontal change, which is the run. So we got our equation for slope stems from this. The rise over the run. The rise over the run. So now, when we get to our next little equation, what would the rise be? So write this down. If you write this down, it makes it simple and easy for you to do. The rise, okay, is the y value, the change in y. So what we're talking about is when we change something. So if I'm down here and I change to here, that is rising. So it's here, this value at 3 feet, and then 4 feet or 6 feet. So it's 3 to 6 feet. What's the change? 3 to 6 feet. 3 to 6 is how many feet difference? 3 feet. Good, Grayson. 3 feet. So when we talk about that, that's what this is. That's the rise part. The run is how far across it went in the process. So that is x value to x value. So it's 4 to 5. That's one change, your change. So you're going to change vertically and change horizontally. If you remember this equation, you'll be fine. So we did 3 equations today. Distance, midpoint, slope. So here's what you have. Look carefully at our drawing. The rise is the y value, the run is the x value. That's how you're going to determine your slope of a line. Okay? How far a line is sloping. Okay? So when you look at a slope, you will find 2 things, 2 values that are important. The first is that they change vertically and they change horizontally. Okay? So here's the problem. We have only a few minutes left in class, so we've got to hurry. We've got to hurry. Okay? All right, so it looks like this. All right, so we have our slope, and if you pick carefully with me, you'll see 2 points. You'll see 2 points on this line. One, right here. And somebody tell me, you see that point, and this is the origin. So it's 1, 2. So if you put little parentheses here, it is 0, and it's up how many? 2. Well done. Now, you need to find another point where it crosses the line. So, watch carefully. It is 1, 2, 3, 4. 4, it's positive 4, and it's down 1, so it's negative 1. So, when you have that in your equation, when you know what that is, that helps you. Okay? So, once again, your rise, okay, by the way, your rise, okay, so watch, from here to here is up how many? It's 3. How do you know that? What's my equation? y2, y1. x2, x1. What are my numbers? What are my numbers? So 2 minus negative 1 over 0 minus 4. Right? So what do we have? When I do that, what do I have? I have my rise of what? My rise of what? 3, good. And my run of negative 4. My slope is what? Negative 3/4. That's my answer. Okay, so you can see it on the drawing. The rise is negative 3, because in other words, it goes down 3. And it runs 4. Okay? So therefore, you're going to be negative 3/4. Okay? Now, let's look at the next one. This one's not drawn for you. So what are you going to do? Remember, always important that you mark your x1, y1, x2, y2. So we're going to set up our equation. And we go right to our equation. Remember, what is our equation? Our equation is slope equals y2 minus y1, x2, x1. So once we have that equation, we go right into plugging in numbers. Plug in numbers. This is our y1, this is our y2. So here we go. Look carefully with me. I'm going to erase this so you can see. So it's negative 2 minus 4, 3 minus 1. So do the math. 2 minus 4. 2 minus 4 is what? 6. Good. And 3 minus 1 is 2. So we have 6 over 2. So what's my slope of that line? The slope of the line is actually 3. 3. All right? So, any questions on that? You use your equation, you plug it in, and you solve. All right, now, here are some things you need to know about slope. These are some important concepts about slope that you will need in order to continue solving problems. So the first is when moving from left to right, okay, when moving from left to right, so in other words, so you're starting here and you're going that way. Line with a positive slope slant up, and those negatives slant down. Does that make sense? So if we're moving left to right, we're going to go up for a positive slope. We're going to go down for a negative slope. Okay? So that's important. The slope of any line is the slope of any horizontal line. In other words, a horizontal line, it means a line that runs straight across. Horizontally is always 0. The slope of a line, of a horizontal line, is always 0. So that is important to write down. Don't worry about this first statement. It's something that is important, but it's not going to be something I'm going to test you over. You really need to know this line. So slope and is 0. Slope, horizontal line is 0. The next one, the slope of a vertical line is undefined. The slope of a vertical line. So if it's going straight up and down, see this line on this page right here? That is a vertical line. The slope of that is undefined. Why can't you define it? Because you don't know where it's going. It's just going straight up and down and you can't do anything with it. All right? Can't do anything with it. All right? Now, so we have parallel slope postulate. We're going to zip through this. Any two vertical lines are parallel. We're not going to go over this. I don't think that is not crucial to surviving. All right. This is important. Perpendicular slope. This is important, and it's very simple. It says this: if I have two lines, okay, if I have a line that's like this and like this, then the two slopes, okay, the two slopes, when I have them, are going to give me, their product is going to give me a -1. That is important to know because, why? That way you can solve something if they give you that answer. So what we need to realize is if you have two perpendicular slopes, if those slopes are perpendicular of each other, what you will have is, you will have their slopes product to be -1. That is just something that's important and to follow and know. All right? All right. Our next one is one of our examples. Okay? The example, use the following points to determine whether each pair of lines is parallel, perpendicular, or neither. So what do you do? What do you do to determine what set of points, okay, what set of points is that? So AB, CD. Those two sets of points, and what we're going to determine is whether those lines are parallel, or whether those lines are perpendicular, or whether they're neither. One of those three has to be determined. How we get that is by doing what? We have to identify the slope. The slope of parallel lines are equal. The slope of perpendicular lines, product, in other words, multiply together to get -1. And if they don't have either of those two, then they don't work at all. So once again, parallel is they're equal. Product, -1. Neither, we won't have anything in common. So we start by first determining AB. That's a line, and what does that line do? That line does one of two things. The line does one of two things. The first thing it does is you got to find out what the slope is. What will the slope be of -3, 4, and 3, 2? So what you have to do is you have to figure out what that slope is. That slope is going to be 1 over -3. How do I know that? I know that because, remember, slope of AB is y2 minus y1, 3 minus 3. So 2 minus 4 is -2, good. And 3 minus -3 is 6. If I reduce that right here, I get a -1/3. Okay, does everybody see that? Any questions? Does everybody see my writing up here in the corner? -2 over 6 gives you a -1/3. Any questions on that? I'll leave it up there for a second. Now, what's the slope of CD? The slope of CD, 1. Okay, so now remember, slope of CD. Remember what we got here. Where's our x1? Or y2, y1. y2, x2. So it's -3 minus and minus 4, and -2 and 1. So when we have that in, does everybody see that? Everybody sees that information, okay? The information there is we have -3 minus 4, because remember, here we go. So we have -4 That's our y1, our y2, our y1, or x1, our x1, 2. So we have it all there, and we do the math. What happens? Negative 3 plus 4 is a positive 1. Good. And negative 2 minus 2 is a negative 3. So what do we have? We have a negative 1/3 and a negative 1/3. So class, let me ask you a question. Remember, quick, carefully, what is the answer? If the slopes are parallel, what do you know? What we know, class, is that if they're parallel, then they're what? Or, I'm sorry, if they're equal, then they're parallel. So these two lines are what kind? They're parallel lines. All right? Any questions on that information? So these two are parallel lines. All right? Okay? Any questions on that?